Today we're going to learn the addition and multiplication property of equalities, and we're going to use this to help us solve equations. So let's begin with a very simple equation. Let's say I give you the problem x plus 2 equals 10. Now that's probably as basic as it's going to get today. But if we have this equation right here, in order to solve it, we need to find the value of the variable. So in this case, that would be x. So our job is to find what does x have to be to make this particular problem true. Now most of us can simply use mental math and realize that 8 plus 2 equals 10. 8 plus 2 equals 10, so we have 10 equals 10. So we can put a check there. We've got the problem correct. Some of the problems you might be able to do with mental math, but for other problems that are slightly more complicated, such as 5x plus 2 equals 3 times the quantity x plus 1, we're not going to be quite as capable of doing this with mental math. So we need a strategy, and today that's what we're going to learn. We're going to learn a strategy, a foolproof way to find the value of x in any problem. So let's begin by discussing these steps that we'll need to solve the more difficult equations. I would highly suggest to write these down and keep these in a place where you can come back to them if you get an equation that is quite challenging. Step 1. Simplify both sides of the equation. In order to solve an equation, both the left-hand and the right-hand sides of the equation need to be as simple as possible, and we will use some of the steps that we learned yesterday to simplify these. If you'll remember yesterday, we simplified expressions using two strategies. We distributed and we combined like terms. So if you see a set of parentheses and there's a number on the outside of it or a negative sign, you're probably going to need to distribute. Once you're done distributing, if you have terms that have the same variable, you're going to need to combine like terms. The second step is to move the variables to the same side of the equation. You won't always have to do this, but if there are x's on both the left and the right hand side of the equal signs, we need to get those on the same side in order to solve for x. And finally, the third step is to isolate the variable, or the way we usually say it, I guess, get the variable by itself. So, to recap, the first thing we need to do is look at both the left and the right hand sides and see if there's anything at all we can do to make it more simplified. And that means see if you can distribute, see if there's any like terms you can add together. Once you've done that, check both sides of the equation. If there's a variable on both sides, we need to get them on the same side of the equation. And once everything is simplified and once you only have one variable in the equation, it's time to start getting that variable by itself. At this point, it's probably a very good idea to pause this video and write down these 3 steps, as you will use them very often throughout the rest of the notes and in your homework assignment. So now that you have those steps written down, let's go ahead and jump right into this and start solving some equations. So we're going to start with an easy one. We'll call this example A, and we'll go x minus 1 equals 15. And there's our first problem. What I've always done to start these equations is I like to separate it into left-hand and right-hand side. So I'll do this every time, and I highly suggest doing it as well. I like to draw a line right down the equal sign. And that gives us, what that gives us, guys, is it gives us a left-hand side and it gives us a right-hand side. And it kind of keeps them separate from one another. So this line right here just seems to help a little bit. Now we always have to check and see if we can simplify either side of the equation. And we also need to just real quick check and see if there's a variable on both sides. This is a simple equation. There's nothing to simplify, and there's only one x in the problem. So we can go ahead and skip to that last step, and we can start isolating the variable. So we can start getting x completely by itself, which means that we need to move this right here. Once this is gone, then x is going to be the only thing on this side of the equation. Again, that's another reason I like to draw this line. We want x to be the only thing right there. So at the end of our problem, we want it to look like this. We want it to look like x equals and then some number. So that's what we want this to look like. So let's go ahead and begin. We need to get rid of this minus 1. Well, we have to do something called inverse operation. This is key to this whole process. Inverse operation simply means the opposite. So, opposite operation. The opposite of addition is subtraction, the opposite of multiplication is division, and so forth and so on. So in this problem, we have a subtraction problem. The opposite of subtraction is obviously addition, so that's exactly what we're going to do. We're going to do the opposite. So we're going to go plus 1, and we're going to go plus 1 to this side. It's very important that if you do something to one side, you always do it to the other. So if you do it to the left side, you have to do it to the right side to keep it balanced. Now, what we can do is minus 1 plus 1, well, those two things cancel out. They're gone. You can check it on your calculator. Negative 1 plus 1 is 0. So we did it. X is the only thing left on the left-hand side. We go to the right-hand side. 15 plus 1 is 16. We've got our answer. X equals 16. But before we can move on, we need to check and see if this is correct. The way we check and see if this is correct is we take our answer, 16, and we plug it into the original problem. So let's do that real quick. 16 minus 1 equals 15. Is that true? Well, 16 minus 1 is 15. 15 equals 15. Check. We're good to go. Let's do another real quick one-step problem just to make sure we're comfortable with it. We can call this example B. And let's go negative 2x equals 8. Again, I like to start by drawing a line through the equal side to give us a left hand and a right hand side. There's nothing to simplify. There's only one x, so we can jump right in and we can start isolating this x. Let's get this x all by itself. At the end of our problem, we want it to look like x equals something. That's our goal. So let's go ahead and do this. Negative 2x. Anytime you have a number pushed right next to a variable, then that operation is multiplication. We talked about that a little bit yesterday. So the inverse of multiplication is division. So we're going to divide by negative 2. Don't forget the negative. And we're going to divide by negative 2 on both sides. Again, always remember that if you do it to one side, you have to do it to the other to keep it balanced. So negative 2 divided by negative 2 cancels out. We are left with just x on the left-hand side. 8 divided by negative 2 is negative 4. Done. We've got our answer right there. Let's go over here and check it real quick. We always want to make sure that we did it correctly, so we're going to take this negative 4. We're going to plug it in there for the x. So we've got negative 2 times negative 4 equals positive 8. Well, negative 2 times negative 4 is 8. 8 equals 8. We're going to give ourselves a big check mark. We got it right. The cool part of these problems are that you can always check them to see if you got it right. There's no guessing. You don't have to wait to plug it into My Math Lab or wait till your teacher tells you if you got it right or wrong. That's the cool thing about this. So as long as you're not lazy and you're willing to take the extra maybe 5 or 10 seconds to plug your answers in, you always know if you're right or wrong. There's no excuses with this type of stuff. I think you guys should have one-step equations down pat. So let's jump into the problems that are a little bit more challenging where we'll have to use those first and second steps. So let's write down this problem. Let's call this example C. Let's go 8x plus 2 minus 2x equals 9 plus 5x minus 2. So some of you might be saying, whoa, 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 this is a lot harder than the last problem. And granted, there's going to be more steps, but if you follow those sets of steps that you wrote down at the beginning, you're going to do just fine. So let's draw a line down the center. It's always a good way to get started. Again, that'll separate our left-hand side from our right-hand side. So what I want us to do first on this particular problem is I want us to forget that this particular side even exists. Pretend it's not there. We're going to worry about it in a minute. And the reason why we're pretending it's not there is because right now we need to be worrying about this side of the problem. We'll worry about this side of the problem here in a little bit. So we've got to look at it. Is there anything we can do to simplify this side of the problem? Go look at your notes. There's two things we do to simplify. One is distribute. The other's like terms. There's no parentheses. No parentheses means no distributing. But there are like terms. We've got an 8x and we've got a minus 2x. So we need to combine those first. 8 minus 2x gives us 6x. We talked about it yesterday. This plus 2, since there's no x, it does not have a like term. So we simply drop it right down in the problem. So we've got plus 2. The left-hand side is now simplified. The left-hand side is now simplified, so we can bring this back into the problem. And now we can forget this side of the problem. I think it's really important that we don't get overwhelmed with both sides of the problem. Right now we need to focus on one side of the problem, get it simplified, focus on the next side of the problem. So I really do like to cover it up. It might not be a bad idea to ask your teacher for an index card so you can cover up each side. It's kind of like we're doing with these pink boxes. So let's go ahead and rock with the right-hand side. There's no distributive property. There's no parentheses. Skip. We can skip it. Are there any like terms? There are. What are the like terms? The like terms in this problem are the 9 and the minus 2. Again, don't forget the whole minus 2. So we've got positive 9 and we've got minus 2. So positive 9 take away 2 would leave us with 7. The 5x does not have a like term because the other two terms do not have x's. Drop it down, plus 5x. Now we can get rid of this box. We are ready to go. Don't forget to throw an equal sign. Always keep dropping that equal sign down. So that was the first time that we had to simplify the problem before we started. It's also the first time that you notice that we have x's on both sides. And if you'll look at that list we started at the very beginning, you'll notice we can't have that. And our second step is to get these x's on the same side. So pick an x. Doesn't matter. I usually go with the smaller of the two x's. So in this case, I'd go with the 5. Sometimes I ask my students, if I asked you to carry a piece of paper or an entire filing cabinet to the gym, what would you choose? Well, the smart student would say I'd pick the piece of paper. And typically, that's what most of us would do. So we typically try to move smaller things. So in this particular problem, we're going to move this 5x, and we're going to move it over here so it's on the same side with the 6x. So we're going to take this 5x, we're going to move it over here with the 6x. How do we do that? Well, again, it always comes back to inverse operations. That's what it keeps coming back to. This 5x right here is positive. Notice we have that plus sign, so this is positive 5x. And since it's positive 5x, we're going to do the opposite. The opposite of positive is negative. The opposite of plus is minus. We're going to go minus 5x. 5x minus 5x is 0. Goodbye. If we do it on one side, you must do it on the other side. So we go minus 5x. And we are left with 6x minus 5x is just x. Some people might say, Mr. Schulte, what about the 1? Well, you can put a 1 there, but since what we're trying to do is get the x by itself, putting the 1 there just complicates it, so you can just leave it regular old x. So let's bring everything back down that we haven't used yet. So we'll bring down the +2, we'll bring down the equal sign, and we'll bring down the 7. So now we went from having a very seemingly large, complicated problem into having a pretty basic problem. We've got the x by itself, finally. There's no simplifying, so it's time to start using inverse operations to solve this problem. We have +2, and the opposite of +2 is -2. We do it to this side, it cancels out. We do it to the other side, we always have to keep it balanced. X equals 5. There we go. I'm going to go to the next slide real quick to show you how to check this problem, since it's a little bit more challenging. The problem we started with last time was 8x plus 2 minus 2x equals 9 plus 5x minus 2. And if you'll remember, I'll put it down here, we got x equals 5 for our answer. So how do we check to see if this is right? Again, I like that line there. What we'll do, now that we know that x equals 5, we know that this 5 and x are the same thing, so we'll take this 5 and we'll put it in right there for that x, we'll put it in for that x, and we'll put it in for that x. So we'll put it in for every single x in the problem. So we'll go 8 times 5 plus 2 minus 2 times 5 equals 9 plus 5 times 5 minus 2. So if you work this out, you're going to get the left-hand side to equal 32, and you're going to get the right-hand side to equal 32. And since 32 does equal 32, we can say that we did a great job and that this was the answer. At this point, after doing these examples, you should be ready to do the first 11 problems on your homework assignment. Take your time. Please follow those 3 steps. Simplify the left and the right-hand side. It might not be a bad idea to ask your teacher for an index card so you can cover up one side of the problem while you work the other side of the problem. After you get done simplifying the problem, make sure you don't have x's on both sides. If you do, get them on the same side. And once you have gone that far, you should be able to isolate the variable. So go to your homework, pause this video, come back to it if you have any questions, and get the first 11 problems on your homework assignment completed. Okay, hopefully you were able to get the first 11 problems of your homework assignment done. We're going to go ahead and move forward, and we're going to start doing problems that require you to do 2 steps to isolate the equation. So, our fourth example, we'll call this example D, will be as follows. We have 5 over 3 x minus 7 equals 2. We'll draw our line down the center of the problem, and we'll start to look and see what needs to be done. There's no simplifying necessary. There's nothing we can do. This is as simplified as it comes. You can't add these together. This has an x, the 7 doesn't. There's no distributive property, so we're good to go. This is the only x in the problem right here, so again, we're good to go. So let's start getting this x completely by itself. Again, remember, at the end of the problem, we want the problem to look like x equals something. So what we need to do is we need to move two things this time. So far we've only had to move one thing, but this time we need to move two things. We need to move both this -7 and we need to move this 5/3. So really the only question we have is, which one do we move first? Do we move the number with the variable, this 5/3, or do we move the number that's out to the side of the variable, the -7? Well, we always move the number that is not with the variable first. I like to think of the number that is with the variable, in this case 5/3, is hanging on to this variable very, very tight. So it's going to be harder to get rid of this variable. So again, we always move the number that is not with the variable first, and in this case, it's -7. So let's move this -7. Again, it comes back to inverse operations. This is -7, so we're going to do the opposite. We're going to go +7. -7 plus 7 cancels out. We do it on this side to keep it balanced. And we're left with 9 equals 5/3x. There we go. We're one step away from getting this variable isolated. So our last step is to move this fraction. Now, I'm assuming at the beginning of the problem you're already a little bit intimidated because we typically don't like fractions. But honestly, you have nothing to worry about because it's really not that much different. This 5/3 is pushed right next to the x. And anytime you have a number, whether it's a integer, a decimal, a fraction pushed right next to a variable, that means it's a multiplication problem. So again, I keep saying inverse operations. Go back to do the opposite. Do the opposite. What's the opposite of multiplication? It's division. So we're simply going to divide both sides by 5/3. So we'll divide this side by 5/3. We'll divide this side by 5/3. We always want to do it to both sides. And we get x equals 27/5. So that looks like kind of a bizarre answer, and you know, it kind of is, but let's see if it works. We might be right. There's a very good chance we are right. So we're going to take our answer, we're going to take 27/5, and we're simply going to plug it in for x. There is no need to guess, and there's honestly no need to worry about this weird answer because all we have to do is check and see if we've got it right. So let's plug it in. Let's see what we've got. So we've got 5/3 times 27/5 minus 7 equals 2. Well, let's see if all that stuff does equal 2. Let's type it into our calculator. And I'm typing it in mine, blah, 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 da, da. And I get 2. Give ourselves a big check mark. So don't freak out when you get a fraction as an answer. Fractions are perfectly fine, perfectly normal answers. Let's do one last example that uses all of the steps. I don't think we've used one that uses all of the steps yet. So here's our final example. Example E. If you can do this example, you should be able to do most problems that come your way. So, let's begin. 5x minus 10 plus 6 equals 40x plus 28 plus 5x. It's a long problem. Don't be intimidated. Let's start by drawing that line down the center of our problem, center of your page. And the next thing I'd like you to do is I'd like you to take something, take the top of your calculator, take something, anything really, and cover up this side of the problem. I don't even want to think about it until we get the left-hand side simplified. So let's look at the problem. It doesn't have the distributive property, but what it does have is a set of like terms. We've got -10 and we've got positive 6. Negative 10 plus 6 is negative 4. So we've got 5x minus 4. There we go. This side can now officially be said that it is simplified. So now let's cover up this side and let's uncover this side. Again, let's not worry about the left-hand side now. Let's fix the right-hand side. Take your time. If you take left-hand side and right-hand side one step at a time, it becomes a lot less overwhelming. Okay, so again, the one thing this problem does not have is the distributive property. There are no parentheses in this problem, so we're not going to have to distribute. But are there like terms? And I think there are like terms. We've got 40x here, and we've got 5x here. Remember, like terms, same variable. X, x. So, let's add these together. We've got 40x, and we've got positive 5x. 40 plus 5 is 45x. A common mistake that people make sometimes is they forget to put the x. So don't do that. Don't forget that x. Let's drop our 28 back down into the problem. And there we go. Now we've got the right hand simplified. So let's uncover this box right here. And there we go. We've got it. Let's put an equal sign in between. So, step 1 done. We have simplified this problem. The right-hand side and the left-hand side are completely simplified. Both simplified. So, let's finish this up. We've got an x on the left-hand side. We've got an x on the right-hand side. We need to get those on the same side. If you remember my tip from earlier, what did I say about which one I like to move? That's right. I said I like to move the small one. So we have a 5x, we have a 45x. I like to move things that are small, so that's what we're going to do. So this is where we could maybe have a little bit of a mistake. So I want everybody to slow down and pay real close attention to this. We do inverse operations. So some people would see this minus sign and say, well, the inverse of subtraction is addition, so I'll add 5x to both sides. Well, that's where you have to slow down. This minus goes with the 4. This minus goes with the 4. The minus does not go with the 5x. I know we don't see it there. But there's a positive. This is positive 5x. So, since this is positive 5x, we need to do the opposite of what's positive, and that is to subtract. So we're going to go minus 5x. Now, ladies and gentlemen, we know that works because 5 minus 5 is 0. If you had accidentally added, 5 plus 5 is not 0. 5 plus 5 is 10. So take your time, and again, remember, this went with the 4, not with the 5. So, we subtracted our 5x here. Goodbye. We subtract our 5x here. And let's copy down what we have. On this side, 45x minus 5x is 40x. Drop down your plus 28. And drop down your 4. Now, I've made a mistake, and I'm curious if you caught it. What mistake did I make? If you guessed I forgot to drop down this negative sign, you're 100% correct. If we have a minus sign here, we have got to drop it down. So I'm going to put my negative right there. There we go. We're ready to move on. We've got a two-step problem. Remember, I want to get my x by itself, so at the end of the problem, I want it to look like this. So I've got two things to move. I need to move this 40, and I need to move this 28. These are the two things I need to move. If I can get rid of the 40 and I can get rid of the 28, then I'll be left with just x. Recall what I said to move first. Always move the number that is not with the variable. So in this problem, it would be the 28. This is what we're going to move first. Inverse operations. Look in front of it. It's plus 28. We're going to go minus 28. Minus 28. These cancel out. We're left with 40x equals negative 32. And we are so close to being done. Last step. Our last step is to move the 40. Again, if you want to move a number, think inverse operations. 40x is a multiplication problem. The inverse of multiplication is division. We'll divide both sides by 40. There we go. We reduce this fraction. This fraction reduces to negative 4/5. And there we go. We got it. We got it. Last step before you go to the next problem is you need to take this and you need to substitute it in there. And you need to take this and you need to substitute it in there. And you need to take this and you need to substitute it in there. And when you substitute it in, you will find out that it works. So that brings us to the end of solving equations. I know there were several examples, and I know some of them got to be a little bit challenging, but I promise you, if you follow those 3 steps, if you simplify both the left hand and the right hand sides first, if you get those variables on the same side, and finally, if you isolate that variable using inverse operations, I know you will do fantastic. Take your time, always check your answers, and you'll do great. You should now be able to finish the rest of your homework assignment. If you have any questions, please don't hesitate to raise your hand and ask.